Hello, my name is Ryan Hare, and today I'll be giving a presentation on how we can use serious games to fill in for tutors or to tutor students. So I'll go over what makes a game serious. I'll go over how a game can tutor a student, how it compares to a real tutor, and what parts of the game are needed to make sure that that tutoring works. I'll talk about what kind of data a game would collect, why it needs it, and how it can turn that data into actions. So, first of all, what makes a game serious? Well, if you think about Minecraft, it's a very popular game. Many people have probably heard of it, seen it, or at least know the name. No matter the format, games like that are made for entertainment. So when you call something a serious game, you're talking about a game that is not purely for entertainment, rather, something that is for education, training, or other serious uses. And a few examples of serious games, and I just found these through a brief search online. There are games that do scientific experiments. There are games that replicate lab experiments that students might do in a chemistry course, for example. There are games that teach students how robotics work. There are even games that do a more general approach and just try to teach students the scientific method through exploring an environment, doing some experiments in a virtual world, or something else. All these games and more are out there, and they are, well, meant to be more exciting than a typical lesson, meant to be more enjoyable, more engaging, or somehow give you educational content in a non-standard way. But how can a game be a tutor? Well, if you consider a human tutor, they have to make some observations of how the student is performing, maybe ask them some questions, watch them solve a problem, something like that. And then they would have to know the student's area of difficulty. This is just past experience, knowledge, something like that. And then they would need to think about how to help. And this falls into the idea of like human intuition. If you see someone doing something that you know how to do, you can usually think about how you might help them, how you can suggest hints to them, how you can give them ideas, or how you can push them in the right direction. Well, a computer doesn't have human intuition. So instead, we have to use sensors. We have to gather data on the player, on the student, and use that to guess how the student is performing. We also need to gather, well, as I said, gather a lot of data. That could be through sensors. Maybe you have some face tracking, eye tracking. Maybe you are just looking at their responses to questions you're giving them. And then use some sort of artificial intelligence method to make that connection, to take that data and to give some human-like responses to the player to push them in the right direction or to tutor them. And so with all of this, data is very important. The human tutor, well, a human tutor can interact with a student and see how they're doing. A game or a system doesn't have that luxury. Instead, it needs to gather a whole bunch of numbers, gather data on how long a player is taking, gather data on how well a player is performing, all of that stuff, and then it can start making decisions. And I mentioned a few ideas there of time and how well a player is performing, but specifically, it gathers a lot of numbers. When games tell you that they're going to collect some data, it's probably numbers. It's probably time taken to complete sections of the game, number of mouse clicks. Maybe your mouse was hovering over a specific answer for a while. Maybe there's some responses to open-ended questions, or there might even be some emotion estimation. With webcams, you can look at a player's face and try to guess what they're thinking, try to guess if they're happy or frustrated. And so, with all this sort of data, just like a human tutor, these serious games can consider what a player is thinking and how well they're performing. Excuse me. But what kind of adaptation can a game do? How can a game use that data to adapt? And what can it do to adjust the player's experience? Well, these games can use artificial intelligence methods to turn player data into decisions. It can modify the game's story. It can change parts of the gameplay, can make it more or less difficult. There's a few examples of games out there that will make the game more difficult if the players are progressing too quickly. Things like that. I've even seen some games that change colors of certain objects to draw the player's attention or make them less distracting. And then, of course, the game can also provide hints to the player, can push them in the right direction, can give them support. But what does this kind of artificial intelligence look like? If we have these things that we can do, say we choose what color the background is, say we choose what hint to give the player, say we choose how to create a hint, anything like that. How do we turn that player data into a decision? Well, one way is through what's called classification. And classification, you can see on screen, there's a couple examples here, is essentially grouping players. If you had a game that dealt with mathematics, say you were trying to tutor players in multiplication and division, you could look at the player's performance. Say these plots down here, the axis here represents how well they did in multiplication and how well they did in division. Maybe red players are players that need help with multiplication, and green players need help with division. So these types of artificial intelligence methods will look at the different groupings of players and try to split them, try to say which group a player belongs in. And you can see there's some overlap in the middle where it gets a little fuzzy and it's hard to tell which group a player's in. That's why these methods aren't perfect. And the more data they have, the more accurate they can be. In addition, some of the more advanced methods have certain ways of dividing up the data or making sure that the players are getting into the right groups. Once you have those groups, you can give those players support depending on what group they're in. Some games can even learn how to help players. There's methods called reinforcement learning, and these methods allow the computer to repeatedly choose interactions to give to the player. Say they keep choosing different hints. Well, if the player responds positively to those hints, the system gets a good reward, literally a number, and the system wants to make that number go up. This is the same way that scientists have been training robots to move robot arms and place objects in certain positions. As these systems interact with more and more students, they learn how to be better tutors. But that's more or less everything. A basic summary of how serious games can tutor students. Thank you very much for watching.